Episode 36, Build, Interior Doors. We were on the lookout for our interior doors. One day at the start of October, my wife dropped by the local Habitat for Humanity Restore. They specialized in items that are used but in good shape. As my wife arrived, she saw a worker unloading a door from a semi. She asked if she could buy the door. The Restore guy said, "You can buy them all if you want." There were 34 doors total, all 8 foot tall, solid alder. Some were carved, some had mirrors, all had hardware and hinges still attached. She asked what the price might be. "Well," he said, "it's going to rain this weekend, and we don't have room for these inside. If you take the whole lot, I'll give them to you for half price." Still the question remained, how much? "Well," said he, $3,500 total for everything." She said sold and wrote a check. It wasn't just the 34 doors with hardware and trim. It was also all the baseboard, crown molding, multiple sets of California closet inserts with drawers and racks. What a great deal. Just one of the double-wide, solid alder carved doors alone is worth $3,500. We rented a U-Haul trailer, and it took several trips to transport the doors to our home. They took up several stalls. In February, 5 months later, we eventually rented a large trailer, hooked it up behind my truck, and hauled the doors, closets, and trim the 1,200 miles to the build site. The roads were very icy at times, and the load may have been up to 10,000 pounds. Not sure. I never weighed it. Once we arrived up north, there was quite a blizzard as we placed the doors and California closet items inside. We unloaded all the trim and molding into the unheated garage. And I'm filming you with the blizzard. Here, come over here, bud.
Very, very cold out. It's horrible out.
It was extremely important that when we framed in the walls, we ensured that they were plumb. Taking the time to make it right up front prevented issues later on when we were hanging doors and drywall. It was really nice to get these large, hand-carved, double-wide doors hung. They fit perfectly and gave us the look for which we were looking. We had some openings that were not 8 foot tall. We needed to cut down some of the doors so that they would fit. I removed the door from its frame and then disassembled the actual door, removing the top 8-inch plate. After removal, I cut down the upright slats on the door and then placed the top plate back on. When the door was complete, I cut down the frame to match the new door height. During our iterative design process, we decided that it would be nice to have some of the doors be pocket doors. We researched pocket door hardware online, but most of it could not handle heavy, 8 foot tall, solid doors. We eventually found industrial quality pocket door hardware from Johnson Hardware Fevco, and we couldn't be happier with it. The link is in the description. One thing that we've got in here, which is really neat, are sliding doors. And they really nice glide systems on them. They silent, smooth. We've got a sliding door there, another sliding door here. It really makes it easy as far as space considerations to have the doors like that, as opposed to having a door with hinges, where you simply put it into pocket door into the wall. And when you install those, they've got this metal frame that they ride on that you set in and balance all out, and you screw the top assembly on, hook them on the wheels, and they're good to go. The doors are great. We couldn't have had a better find. Episode 37, Build, Water Supply. The first step in getting the water in was to get the water from the well to my utility room. The property had an old well on it that was open on the top, had a rock lodge partly down the pipe, and had a hole cut 7 feet down on the existing 4-inch well casing. The existing well was 50 feet deep, 20-foot static level, providing 16 gallons per minute. To repair the well, we installed a new upper casing and new pitless adapter. We were also able to remove the rock. We drilled a side hole outside of the foundation to allow for the well pipe to be under the foundation. We laid a 3-inch PVC pipe with no more than 45-degree bends from the well to the future utility room, so that a 1-inch well pipe could be later snaked through the 3-inch PVC. Once I had the utility room built, the walls framed, the drain waste vent pipes, and the electric wires routed, I began to distribute the PEX lines from the utility room through the house. I had elected to use a home-run mana block. You see here both a large and small mana block. The large one is for all of the house interior water, and the small one is for the external hose bibs. Each fixture in the timber frame has its own hot and cold shutoff in the utility room via the mana block. This is in addition to the shutoffs at the fixture. The next items that I installed were these PEX bend supports next to the mana block. These reduced the chance that I would crease the tubing, allowed for greater control, and resulted in a professional-looking install. Now it was time to begin routing PEX from my future fixtures to the mana block. These first 2 PEX tubes are from the guest bathroom sink. As I continue to install more PEX, you can see the value of the 90-degree PEX bend supports. One side note, the mana block recommends that you use these black plastic connectors for your PEX pipes. The PEX is crimped onto the plastic. The seal is made with a small washer between the mana block and the connector. These leak if they are not perfectly installed. After hours of trying to stop various leaks, I threw in the towel and instead ordered these connectors. They use a different sealing method between the connector and the mana block, and for me, they have been leak-free. Remember that all of your brass in potable water must be lead-free. At the fixture end of the PEX tubing, I had a number of areas where the PEX comes up vertically through the framing base plate, but needed to come out horizontally from the wall. This was true of all sinks and toilets. To bend the PEX without creasing it, I installed a 2x4 block 3 to 4 inches below where I wanted the tubing to exit the wall. I then drilled a 3/4 inch hole in it and nailed this support on the 2x4 so that the holes lined up. Now when my PEX came through that 2x4 vertically, I could bend it 90 degrees to come horizontally out of the wall. The other fixture items I installed after the PEX was through the finished wall, interior-exterior, were these 3 valves. Note the washing machine box with hammer arresters. This is what you need. It was quite a job routing all the PEX tubing through the house. I now had electrical wires, LAN wires, drains, vents, hydronic PEX tubing, and potable water tubing running everywhere. I tried to be neat, but there's only so much that one can do. Now it's finally time to bring the water in from the well. We snaked a 1-inch flexible well pipe through the 3-inch PVC and had it in the utility room. I took this well pipe and connected it to a T-pack pressure regulator. That is a device with the gray box and pressure valve on top, and the spigot out to the side. From the T-pack, we tee off into the pressure tank. From that tee, the water then continues back behind the pressure tank. The pipe goes along the wall and then up on the right in the white pipe. The white pipe is non-softened water. The white pipe turns left and goes into the small mana block. The 3 white pipes coming out of the top of the small mana block are for the external hose bibs. On the left of the small mana block, the white pipe continues out and then goes into the large white device, which is the water softener. The silver then blue pipe exit the water softener, and this pipe enters the bottom of the large mana block. Once the cold blue water enters the bottom of the mana block, it exits through all of the blue pipes to the house fixtures. The top blue pipe with the brass fitting goes over to my combination boiler and the water is heated. The water then returns back to the mana block via the red pipe at the top. This hot water is then distributed out of the mana block via all of the red pipes. Now there were only a couple things left to do. First, we needed to analyze the well water. We purchased a kit online from Simple Lab. Their link is in the remarks. The results of this test will let you know what type of filtration and water softener to put on your well. My results were easily corrected with a water softener. You also need to test for bacteria and molds. This is a different test. We used a test from TapScore. The link for that is also in the comments. Last, because we had replaced many items in our well, we needed to disinfect it. To shock the well, we followed a procedure put out by the University of Georgia. The link is in the comments. The wet volume of our well is about 20 gallons, with a total pipe volume of about 33 gallons. The shock treatment took less than a gallon of unscented bleach, and the well was disinfected and ready to use.